career has been, and the development of 18 labs specializing in EMC, ENV, safety, RF, etc. Then he's helped over 110 organizations to meet local and global certification needs of the product. So his latest venture involves platform synth EMC AI. He'll talk about that in partnership with Elfonze Technologies, which aims to provide AI/ML integration solutions across labs, OEMs, research organizations, and policymakers. His dedication is instrumental in advancing India's position as a technologically sophisticated nation. So with this introduction, let's give a warm welcome to all of them, and over to Sanjeev.
Thank you, Mr. Rao. Appreciate you taking time to introduce all of us. Good afternoon, ladies and gentlemen. Our topic is Masterclass for Electronics and IoT, and particularly this is focused around startups and MSME. So, while I'm kicking off this event, first I would like to give you a background about where is electronics industry today in India and what the future looks like. As Mr. Rao mentioned, we are part of the DFM team in TIE, me, Prasad sir, Rao and Rahul from T Connectivity. We four are the key members in this DFM initiative. And our charter is to really support startups from design to manufacturing. And here we are having quarterly webinars on different technology topics. We already had webinar on connectivity solution, how to design power supplies, how to design electronic circuits, and also on certification qualification by Dr. Ananth some time back. And we'll continue to have that series. But apart from that, we have also created a mentor pool where we are going to have technical support for startups in their design activity. So that is the second thing we have initiated at DFM under the TIE Bangalore chapter. Now let's talk about electronics industry. Last year, total electronics consumption in India was around $120 billion. And out of which 80 billion was manufactured in India, $40 billion was finished good import. With the production link incentive policy by Government of India, PLI schemes, we have seen in last 5 years, so many electronics manufacturing has grown substantially. Now we are producing mobile phones worth almost $30 billion. There is a PLI policy for telecommunication, air condition controllers, LED, automotive electronics. But in this process, what has happened that though the manufacturing ecosystem has built, most of the manufacturing happening on the CKD kits. Like Apple, Samsung, Oppo, Vivo, Xiaomi, all these people are manufacturing mobiles in India. But they get kit from their either headquarter or a kitting supplier, and we just do SMT assembly in India. So what that means, we get only 10% of the value. In a $100 phone, India gets only $10. And then we have PLI scheme to support 4 to 6% of incentive. So eventually we make only $5 in a $100 phone. So imagine in a $30 billion manufacturing of mobile phone, India has hardly made $3 billion. Same case with consumer electronics. Samsung, LG, Sony, they import their kits and do assembly work. Same case with IT hardware. Dell, HP, Acer, they import their kits and do only laptop assembly or desktop assembly in India. So whatever $120 billion market we have, consumption of electronics, ground reality is value recognition is less than 15%. That means India made only $15 billion in $120 billion. Still, $105 billion has gone out. Now, as per report by Ministry of Electronics and as per various report, this $120 billion in next 5 years is going to be $300 billion. If we continue at 15% value addition, even the market will be $300 billion, we will make less than $50 billion. So that will be disastrous. $250 billion worth of forex will go in importing components, importing various technologies. So critical need for India is how we can improve on value addition in electronics. Now let's try to analyze value chain of electronics. Today, 40% value is in components. Out of that 40%, 25% is semiconductor, 10% is passives connector cables, and 5% is bare PCB. We are importing more than 90% components. Semiconductor zero. To some extent, we do passives, capacitor, resistor, but again, 90% of it is imported. And bare PCB in $80 billion production, 5% means $4 billion is PCB market in India. Our domestic manufacturing of bare PCB is only 300 million, less than 10%. We produce maximum up to 8 layer PCB, whereas mobile phone, laptops, they required more than 15 layer PCBs. So we don't have that technology today. So what it means, we miss out on 40% value, which required for component. That is the biggest gap. The second value into the value chain of electronics is in IP and technology. Now India has great talent, but that talent is working either in a captive global center of a global company or as a design services company. Means today we have chip design activity from Intel, Qualcomm, ST Micro, NXP, Microchip, TI, everyone. Top 30 semiconductor companies are India doing chip design. But we don't get IP value, we get jobs. Same case with design services company, TCS, Infosys, L&T, Tech Mahindra. All these companies are doing global design, we get jobs. We do product for someone else. Patents are filed by respective customers' headquarters. That needs to be changed. And how we can change that? Only by creating product innovation from India or chip design from India. So government has come up with this design link incentive scheme for fabless electronics chip design, where 50% of investment into any chip design activity will be supported under DLI scheme. And once that IP core goes into production, there is a deployment link incentive of another 30 crore. So 15 crore for design, 30 crore for manufacturing, total 45 crore incentive is available for fabless chip companies under DLI scheme. Also, government has come up with semiconductor policy where 50% incentive for any wafer fab or ATMP project is given by central government, 20% is supported by state government. So if someone is investing into ATMP unit $100 million, 70 million is going to come from government of India. Only $30 million is required by any corporate to India. But that ecosystem will take another 4 to 5 years to evolve with this good scheme. What is short-term focus has to be is on product innovation. And startups and MSME are going to play a very big role into this product innovation and IP creation. Today, there are more than 10,000 startups working in electronics and IP creation into embedded electronics. What is success rate? It is less than 10%. Why 90% startups are failing? Means the entrepreneur who is just out of college with some bright idea, he takes money from his parents or friends or relatives because there is no funding available for embedded electronic startup. So with his self money, he starts some initiative, and after 1 year, he realized that he has created a POC, proof of concept, or a prototype, but he cannot sell it or he cannot scale up that operation. Why? Because at the design stage, he has not taken a good consideration of techno-commercial activity. What platform will make him successful? Similarly, sometimes what happens, he creates a product, but market demand is different, or competition comes with some another technology. Third challenge is, most of the time these entrepreneurs develop a product with me too idea, that okay, this product is getting sold at 100 rupees, my cost is 50 rupees, I can easily sell at 70 rupees and still make 30 rupees. But he don't realize that Me Too product, the established player, for him dropping price from 100 to 80 or 70 is an easy thing to do because he has already recovered his cost. So most of the time this Me Too idea kills them. There has to be a differentiator, technology differentiator, when you are developing something new. So today we have a great panel, and we are going to focus on 4 challenges what these startups are going through today. First challenge is about doing the right design, design to win. And we have Mr. Abdullah Khan from iWave system. He is one of the best experts in India who can talk on this subject of design. The next challenge startup face is about supply chain. Component availability in India is poor. Any electronic circuit requires at least 50 to 100 different components, right from semiconductor to passives. And you have to deal with 20 different vendors. You have to import some components from Singapore or Hong Kong or Taiwan or Korea, and then you end up paying freight, and you end up holding the inventory because you don't know how much time it will take to get custom clear and production. So compared to China manufacturing versus India manufacturing, there is a disability of 6 to 8% because of all these logistic issue and inventory issues. So how we can address these supply chain challenges? And we have an expert from supply chain domain, Ravi Pagar, who has spent his entire career into supply chain of components. So we will understand what startups and MSME should do to take care of their supply chain challenges. The third challenge is about manufacturing. Okay, because you can't set up your own SMT line, you have to work with some EMS partner. So how to select a right EMS partner? Okay, there are so many options available, and how to really work with right EMS partner. And we have Mr. Vivek Khanna, who is again a great success model of creating a very solid EMS company here in Bangalore at Dodbolapur. Okay, he was actually a corporate person in Motorola, and then started into actually manufacturing of EMS activity. And today, more than 60% of his products are exported. So we would like to understand from Mr. Vivek how a EMS company operates and how startups and MSME can engage with a EMS company. The fourth challenge is about qualification, certification, how to take care of EMI, EMC issues. Because that is also a big issue. You make a prototype, but again, you don't qualify it for export or even for domestic market. So how to get approval for those qualification and certification? So we have Dr. Ananth Krishna, who is again expert into all these certification and qualification. So we are really covering under this DFM panel discussion today, these 4 key challenges faced by startups and MSME, how we can address these challenges. So not taking much time, I would like to invite Mr. Abdullah Khan. Let's start with design. How to design for success? Because that is a critical thing. We have seen 90% startup failing primarily because of wrong design. So how they and iWave is a great success model of creating products from India, SOM modules from India. So let's understand from Mr. Khan about the design aspect first. Over to you.
So, good afternoon, everyone. This one slide. So, it's a kind of nice statement. I start with that, which is basically from NXP CTO. So, from the design perspective or from the technology perspective, whoever takes up the responsibility of that design. First is the technical person with a business background. And we really want to play with the building blocks, multiple building blocks. So we basically it is when you start doing as a design, the person who is responsible for the technology has to play with the multiple building blocks, either internal to the organization or available from external, as if he is playing with the Lego blocks. And as a product, whatever it is, the tendency what we had, let us say 10 years back, we always used to start from a block diagram and start from the schematics and everything. Today's perspective, it is kind of how I create the complete product with the value, whatever we create, the niche content, whatever we want to do, using the building blocks available, which are really proven, and fill up the remaining part. So when we say that the value creation, the first point, so what is it in terms of the niche content that what we are going to do? And traditionally we come from a kind of services background in India, particularly we have done kind of a lot of hardware services, software services. But now when you start developing as a product, there has to be a unique value content. As Sanjeev highlighted, we cannot be a Me Too player or something hardware which is easily available from China, which basically they are doing at a kind of millions of volumes. So what is the real value content? From concept to develop and support and manufacturing and the product life cycle. So there is a kind of value which we need to create as complete life of the complete product. So that is the first thing. And then comes in terms of the modular part, basically there are, when I say that as a kind of building blocks, there are basically some of the building blocks are more generic. and something can be standardized, and something are going to be kind of more specific to that particular product. Right? So what does it mean? For example, let us say I'm a kind of energy metering company. So that energy metering company is specific to, of course, the energy metering part, leaving that the computing part, the connectivity part, everything is available off the shelf. And that company has to focus only on the specific to energy, their core expertise, and reuse all the other modules, whatever is available. Now, previously we used to talk about the processor. Now, if I had to put a kind of embedded Linux, it is a kind of an application-specific processor. That it needed more memory, more cost, and the processing power also that it used to be very expensive. Today, if I can have a kind of Linux-based kind of an application processor, the overheads are not going to be that heavy, but in terms of the development overhead, the software development, and the software maintenance cost, the enhancement cost, that comes down quite a bit drastically. So how do I use that application process? And not just only one. Suppose as a company, what we are doing, we have multiple of products. So when I use that, I use the blocks, the same block, across the products, whether it is a computing part or connectivity part. I standardize all the blocks across all the products, both in terms of the technology and the cost optimization, everything from that perspective. And when I do that, that is what playing with the Legos. That means as part of the product development, I am also going to develop some new modules. So how do I kind of capture that idea and make it as a module and again reuse, instead of allowing our engineers to do every time from scratch. So once a module has been done, proven in a particular product, and basically capture that and reuse across the products. Now, when you say this modular, basically again, a standard-based approach really helps. So rather than making it proprietary modules, proprietary form factors, there are standards have started evolving. So that is the basically follow the modules which are compliant to particular standards, and then that means the corresponding risk factors. If suppose if one supplier is not able to support, you always have another supplier who can fill up that module from one supplier to another supplier. And also, basically, when you make it as a kind of standard, there is not going to be any learning curve, because somebody has done it, it is proven in terms of the CPU or the connectivity or the protocol stack or the operating system, everything is proven. So you focus only on your product as a final end application, what it requires. Everything else has been proven by somebody else. So the corresponding learning curve and the standard form factor and the corresponding risk, if one supplier is not able to do it, there is another supplier who can fill up that module, the block, quickly. So which are the parts which we kind of standardize? Now, typically, if you look at it, any particular electronics, there are around 7 to 8 different blocks. So it is a processor, then power and power management part, the second one. Third is the flash. Fourth one is the DDR, the memory part. The fifth one, basically, in terms of the wired connectivity. Sixth one is wireless. Seventh one is the corresponding application-specific sensors, I/O, or the drive, whatever that is required, and the corresponding connectors. So if you look at this, typically these are 7, 8 blocks. So the first 6 blocks, if you take, most of that can be standardized. And as a product, as an end product, the corresponding connectors, the corresponding I/O circuit, it varies a lot. But the remaining can be standardized, and that can be reused, whatever is available off the shelf, or it can be developed in-house. So when we select such a module, again, whenever you're going to say, buy the off-the-shelf module, we need to be more careful in terms of not just the functionality. For example, if you say, I'm going to select a Bluetooth module as an example, correct? One we can just say is only as a Bluetooth, but there are at least 10 to 12 parameters. If you can take care, then the reusability of the module becomes much more better across product and across as a kind of more long term, rather than looking at it as a short term. So I'm not getting into the details right now. Of course, we can always share our experience. For example, if you take Bluetooth, not just functionality we are looking at, but what kind of profile it support, what is the data rate, what is the distance, what is the certification that it has gone through, whether it is 4.x or 5.x mode support, and does it support extended advertisement, and what is the performance level it is talking about, and what is the kind of host controller it supports, and whether it is a host is required or it can operate independently as a standalone, and what are the kind of package, whether it is USB or solderable or what is a plug-in, and what is the temperature grade. There are, if you take care of course, initially you are going to spend a lot of time in terms of selecting the right module. Once it is done, then the probability of changing the design for something else, it becomes quite a bit. But initially spend more time, shortlist, and then definitely the reusability, the module becomes quite strong for you, and it becomes as an extended module in your product. And then comes the eco partners. So basically in terms of the semiconductor or the distribution or the PCB fabrication, the PCB assembly and the certification. The way we have to work with them is as a kind of ecosystem partner to develop the product, not as a kind of a subcontractor or a kind of just as a supplier. We always work as a kind of more long-term, because each one understands the corresponding pain point. It does not, suppose say I'm going to do that with the PCB assembly. It takes a lot of managerial level, at an execution level, at the test jig, at the way I share the bomb. It takes a lot of learning curve, and it only helps more in terms of the long term. It does not work as in the short term. So the partners I need to select very, very carefully from the start, starting from the semiconductor, going all the way to the certification, and there has to be mutual dependency on long term, correct? I need the partner and they need us. So that is how we have to be selective, rather than considering as a job work, subcontract, finish a job, and move on to the next project. It does not help on long term. And in terms of course, when you select, basically in terms of the reliability, the quality part of it and everything, you take care. Then comes the last part. How do I do that in terms of the design, or the design for excellence? So where the DFM, the manufacturability part, testability part, the assembly part, or the quality part, you have to look at as a kind of, not just as the functionality, as a complete product life cycle, the design for excellence, where all the parameters have to be taken care. So it also depends on the product, whether you are designing a consumer electronics product, or whether you are doing that industrial or medical or avionics or the military. The requirements are slightly different. Everywhere, of course, the target price, the total cost, manufacturing cost is going to be the main parameter, and to be most commercially successful. But at the same time, when you look at the consumer electronics, it's a kind of very high volume, typically we talk about. So the price has to be highly optimized. That means including every resistor, every capacitor, I need to optimize. And also the technology changes very fast. So I need to kind of make sure that the changing technology, the latest processor for that particular consumer electronics product, I need to select, I need to make sure it is done properly. And of course, the ergonomics, basically the compactness, everything matters a lot. But if you take that industrial or automotive or that aerospace, the size is not the criteria, but definitely in terms of the requirements keeps changing, and basically whatever you select, whatever you design, how well you are able to incorporate when the requirements keep changing, how instead of again restarting from scratch, that is very important. And so that means the ecosystem, whomever you are going to work with, they have to also understand, because you are going to change the design little bit, and they have to also kind of understand your change, the design which is getting changed. So it is going to be very high complex, typically in the industrial to the military space, high complex, kind of many variants, and it is a kind of low to medium complex, low to medium volume. So the ecosystem partner with whom you work with, they need to also understand, they cannot expect one single high volume PO at a single point in time. And the product also takes typically 1 to 3 years for the product to mature, for the product to get certified from the design to the certification. So they need to also wait along with you for the product to become successful. And of course, on that space, again, the temperature gradient, whatever the temperature grade, whatever you're going to support. So all those things you take care, but the reusability part is much more in the industrial, medical, and the kind of military requirement. Consumer electronics, you may not be able to do that block-wise because there the size and everything matters a lot, and it's also fast changing. But in the second scenario, industrial and medical, you can do a lot more on the reusability factor. Of course, beyond that, there are challenges in terms of the logistics, the components, the customs, the time it takes to get cleared. There are other challenges. That ecosystem which helps you to realize and make sure it is available to you at the right time, the components are available to you at the right time, or the tools at your space, at your desk. So that plays a major role. That has to be taken care. Definitely, I think there are a lot of initiatives. So I remember whenever we used to order the component when we were in CDOT, if you select a component, it used to take 2 to 3 months to get into my desk. Right? So that has changed a lot. Today, if I order anything on DigiKey and Mouser, third day, fifth day, it is in my desk. So that has changed a lot, but at the same time, still there are some challenges, and I'm sure Sanjeev and his team is working on it. So kind of brief. Thank you.
Thank you, Khan. So now I'd like to invite Ravi Pagar to talk about the supply chain challenges and how component distributor like Millennium is trying to help this ecosystem with the right component at the right time at the right price.
Thank you, Sanjeev, and good afternoon, everybody. I think Mr. Khan has taken masterclass for everybody. So, but still, now since I have the mic with me, I'm going to talk about this. By the way, this is electronic component industry per se. Some people like to call it semiconductor industry. It's not only semiconductor alone; it's like a big gamut of semiconductors, actives, passive components, electromechanical components. Can you hear me now? Excuse me, volume. So, am I audible now? Yeah, thank you. So, coming back again, so it's not only semiconductors in the electronic component world. I think it comprises of passive components, capacitors, resistors, electromechanical connectors, which plays a role up into it. There is another word called as specialty chemicals, which are required for it. PCBs, all these activities which come into this picture. There are one good news and one bad news. It's a very complex world. It's a very vast world, the electronic components. And the second good news is that it is evolving as we go along, and it's improving day by day. Keeping in mind the startups who are sitting here and who are listening to us, I think the needs of the startups are different than a full-fledged manufacturer or a EMS company, which is like Mr. Khanna runs on his Indic Semi. There are different needs for everybody. When a startup is actually starting a new product in design phase, if you look at a complete product life cycle of any product for that matter, depending on where the product is at the design stage, or it is in a prototyping stage, or it is in a mid-volume kind of a production, or very high volume kind of production, such as Apple phones or Nokia phones once upon a time. The needs of the supply chain are different. The people who are delivering these needs are as well different. There are many kinds of distributors. They have formed their own niche in terms of the supplies in the electronic component supply chain. Very different. Couple of names, Mr. Khan already took it. This is a big industry. Largest distributors in the world are almost in the tune of around $40 billion, and they are driving a very mammoth machinery in the world in terms of ensuring that they deliver the products to you. Interesting areas. In the startups, your main requirements are, your quantity requirement is very low in the beginning time when you are actually developing it. That time, you face the biggest and the first hurdle is, how do I get those small quantity numbers? Because if you take any resistor or a capacitor, or for that matter an integrated circuit, the minimum ordering quantity or the standard packing quantity, they call it as SPQ, can run into hundreds or can run into thousands. For one capacitor, one spool actually can be of 10,000 pieces. You don't need 10,000 pieces in the initial stages. So in this case, there are specialized distributors who come into the picture and who can take care of your needs, such as DigiKeys, Mouser, Element 14s of the world, and they cater to all this. They take the reel, they take the entire tube from the manufacturer, they break into pieces and then supply you whatever you require into a different specialized packaging. They carry huge amount of inventory. The number of parts they carry is very high. For example, if you just go and check the DigiKey website, you will find that they must be having more than 2.5 to almost 3 million products in stock at any given point of time to look after your needs. Having said that, what they have done is that they have also developed a wonderful supply chain system, a logistics system, where, as Mr. Khan said, the product, if you order today online, probably it will be delivered on the 3rd or the 5th day in any part of the world, most of the times. And they have established their presence into India. So your first need, who can actually help you to do that for a component requirement for a logistics supply chain, is going to be this kind of a distributor. Having said that, these distributors will not provide you any tech support, will not help you with any kind of a coding support if it is required. Then comes a different breed of distributors. By the way, distributors nowadays, this mid-volume and the high-volume distributors are not simple traders. They don't only buy and sell and make money in between. They are expected to do a lot more value add in between. They have separate teams. We call them as field application engineering team or application engineering team. These are the people who are providing support at the design stage to most of these manufacturers or the product manufacturers in India all over the world. They bring their knowledge. They have vast knowledge of the components. They can also add value in terms of helping you to ensure that your product comes onto the ground, available in the market in minimum time, by providing you sample support, by providing you coding support, and also testing support whenever it is required in terms of the prototyping activity. So that's a different distributor who will come into the picture and who will help you to do that. Now, the question comes, how do we manage the supply chain in terms of the long lead times? In the COVID time, I do not know how many of you faced this issue, but I think the entire world was facing this, and it was the headlines in most of the newspapers in the world. The shortage of components, the lead times. Typical lead time in this component world is roughly around 8 to 12 weeks. That's a very standard like minimum lead time, standard lead time what we have. But in those times, some of the components actually went on a lead time of almost like 2 years and very exorbitant prices. People have paid 100 times than what they used to buy the component. One simple transistor, they have paid possibly thousands of rupees just to procure it. Some of the big automotive majors in this country, I don't want to name them because this is confidential information, they spent in the tune of thousands of crores just to buy shortage components in the last 2 years, especially in the COVID period. And I'm sure what must have happened to the startups who are very humble in terms of their cash flows initially, you must have faced quite a lot of problems during that particular period. So it comes a question of planning. Many a times what happens, when we plan the product initially, that time we are not too sure when exactly it is going to come into the picture, when exactly it's going to come into production, when is the production planning is going to start. It's very, very difficult job to actually incorporate that. And that time, when we consider the lead times can go into the tune of 8 to 12 weeks. It's going to be very difficult to manage your cash flow, manage your stocking levels. And that's where this logistic supply chain people, distributors come into picture, where they can help you to have long scheduled orders by helping you across that. They can invest into finances so that your cash flow does not get impacted. And the last but not least in this particular piece is cost of delinquency. In a bill of material, if there are 100 components, couple of components don't come to you, you cannot start your production, right? Your PCB cannot be completed. A single resistor or a capacitor can cripple your entire production plan. And that's where the cost of delinquency comes into picture. Because you are not losing for the value for the resistor and capacitor, but your entire production is stopped, your line is stopped, and you cannot just move it forward. And that's where it is important that you start working with the distributors or the logistic supply chain providers from a very early stage. And that's what Mr. Khan very rightly said. You have to choose your partners carefully at the initial stages when you're actually building your products. A design house, a distributor, a manufacturer who can help you towards that, and obviously the test labs. Because this relationship goes long way. It is not that only one person is developing a product and he is actually getting the entire credit for that. There is a massive machinery at the back end working with him and helping him to build that particular product. So that's where you have to possibly drive it. Now there are many other challenges which we face and possibly you all face. That is, second one is the trade compliance. Since this is a very complicated word, the US government or the European governments, they ensure that the products which are going into different countries should not be sold out to the people in Russia or in Middle East or Iran, and there are heavy penalties for that. Quite a lot of distributors have lost their business. Quite a lot of people have been jailed in this whole activity just because they were going against the rule, or rather they did not know about this. Now this has to be very carefully vetted and managed, and this is where these people also come into picture. They analyze your businesses, they analyze what kind of activities are doing, who is your end customer, who is going to use your end product. This is going to be a very serious matter these days. I remember last year in the Electronica, when I was on my stall there were 4 or 5 Russian members actually came onto our stall, and they were asking for components because they are in need for that, because there are sanctions on those countries right now from United States. So that's what you have to be very careful in terms of what you're buying. Any IC or any processor which is encrypted, that means we cannot read the code onto it, actually comes under scanner. So this is a product which is called as dual use product, and we cannot support it or we cannot supply it. You have to be very careful about weighing these options whenever you're doing that. The next point in this whole activity is about cash flows, right? Startups, lack of cash, funds, and this is a capital intensive activity. So how do we manage that? So, and that's where, when I said, when you're choosing your component vendors or the component partners, you have to analyze that you're working with somebody very stronger in terms of cash flows. Otherwise, if that particular party is not competitive enough or not healthy enough from the financial standpoint of view, he is going to derail your supply chain. He will not be able to supply you products on time. And at that point of time, you will always have challenges in terms of scouting around and getting the same components from somewhere else. So you have to be careful. The third point, which is again very important, is about managing the product life cycle of the component what you're choosing in your design cycle. Many of the times, the products or the components what you choose, they would have been almost on the edge and getting into the EOL, end of life, in their product life cycle, which you do not know when you select. And by the time you have selected that component, probably that time you will get a sample to build a prototype. And by the time your prototype is finished, and when you go and start placing an order onto the supplier comes up and say, I'm sorry, this is already EOL, we will not be able to produce this. Your cycle begins again. And that's where you start hunting for any part which can go replaced with that. These are the problems I'm sure Mr. Khan has been facing this all across his life. And this happens every time. So whenever you're doing that, ensure that you do the product selection in such a way that you're almost in the early stage, or at least on the mature stage of that product, because it's going to still last for next 5 to 10 years in terms of driving that. Last but not least from my side, in your AVL, right, approved vendor list, whatever we call it, don't be dependent on one manufacturer's brand there. There are a lot of drop-in replacements in every bill of material. You have to hunt for it, get the different AVLs available for yourself. So the risk and the dependency on one vendor goes away. That also makes you very competitive when you start sourcing your products from various vendors, and that will make your supply chain a lot more smoother than it can be. I think that's it I would like to share. If you have any questions, we'll be here available. Thank you so much.
Thank you, Ravi. That was wonderful. Now I request Mr. Vivek Khanna to take care of the manufacturing, which is another big challenge what usually the MSMEs and startups go through.
Hi everybody. Am I audible? Yeah. Okay. Sure. One thing good about, or one thing known about techies are that they're not good orators, except some exceptions, and they're very comfortable when the techies are around them. And it falls true for me at this scenario. So don't expect my speaking abilities, which will be below par. Okay. Coming back to the EMS, you talked about manufacturing. Basically, I'm from 2 decades of telecom software. And so it was a very interesting journey. Why I'm saying it is like, why manufacturing? Because did some startups, and so much learning I got because I happened to be, I'm using the word I in the sense that it was an evolving time for software industry as a services. And we lucky to be there, born up at the right time. And so much learning done during that phase. I mean, the one is that services prevails. The other thing is that this country has so much talent, in particular Bangalore. And I mean, it was a very, very interesting journey, and I luckily chosen the path of entrepreneur, did some startups, and for some good reasons it worked. But then I learned in that game, for an interim period, I was a part of Lucent Bell Labs, and we were working on the telecom CDMA side. And it was a very mature market when we were doing our design work. And I was very surprised the moment I realized that the whole GSM, CDMA, which turned out to be a very mature market in US, and I mean, already been mature for 2 decades, but then the whole GSM taken over. New technology, somebody thought on that, so much easy to adopt. So that gave me a good business reason to understand that obesity sometimes is a killer, because I realized that for US to change the whole CDMA infrastructure which existed in the 80s and 90s, to move it in 2000 to a GSM, not so easily possible. And now in next 2 decades, now you see, take Asian countries, in particular India, we have a very, very well-established GSM and the lowest cost for a telecom, talk. It's a lowest cost infrastructure in the talk. So coming back from the same analogy, I managed to venture into manufacturing. And you'll be surprised that this company, I really thought of more like a startups, which I did in the software industry, and a hybrid model. The reason for that was that my learning was go for the niche areas. Like at that time, I realized the EV and the renewable, I'm talking about my journey in 2010 with Indic, was the 2 niche areas. Of course, every time the IoT is a very integral part of it. So we went into that. Another thing I was a bit confused when I was coming to manufacturing was that everyone told me, my all colleagues, my all friends from IT scenario, are we competing with China? And secondly, we people like an entrepreneur brought up to do startups. Why do you have to do manufacturing to compete with China's of the world on a low cost basis? Because the cost is the integral part. And I realized that no, we'll do a different journey here. And I had a very small team. The only way to do it is the word Sunil talked about was the Sanjeev, is that differentiator. So he said, okay, sure, we'll bring a differentiator. And I mean, we'll do it in a very, very different way where the quality, the delivery, and we'll work with the startups more of the way, which is take the new technologies, never take industrial products or anything like that, the new emerging market. And that's where we started the journey. In a decade time, it's become a very different game altogether. So manufacturing like us are not at all into the mass manufacturing. We are having a very good global ones. Any customers, I'm talking about the key customers who works with us, we tell them we are not at all, from a manufacturing perspective, interested in your existing product. When you start as a startup, when you start coming up with the new products, the new versions, we'll be partnering with you. And you'll be surprised, the journey, like any startups, for us takes about not between 5, sometimes 8 to 10 years for that particular product, which we start from a nascent stage, to get into the real market volume game. So, I mean, I'm trying to bring the analogy into the startup versus the manufacturing. So I see not only that, like parallelly, you'll be surprised that we are not into this mass race of competing on cost. I do very interesting things in my last almost about 14 years of journey with this EMS industry, doing very, very interesting, projects with, or the products, I'll call it, with the Indian Institute of Science. Being an alumni there, I want to give back. And we did very, very interesting things with the robot bots and all that. So please, don't be confused about you being in an IoT or in a startup stage. It's the same journey, whether you do it in a software or you do it in a electronics. It's a very, very long journey. Don't get demoralized by the ones. Be very conservative. I mean, I'm not giving here a gyan or a mantra, because, but I will tell you, there's so much of similarity between the software industry and the electronic industry or the manufacturing part of it. So I think I'll keep it very short, and I'll be ready for the questions whenever it's been asked. Thank you.
Thank you, Vivek ji. Today INDIC is one of the largest EMS in India. So a person from a software industry started a EMS company and grown it to a pretty significant size is really amazing. And the analogy what you gave about startup in software and startup in manufacturing is just fantastic. We will move to the last challenge, which is about qualification and certification. And I invite Dr. Ananth Krishna to talk about the same.
Very good afternoon to all of you. Thank you very much, Sanjeev, and also the dignitaries and the dais. It's been very honored to be here and sharing my little bit of an experience. What I understand is that, when we talk about specifically with respect to the MSME and startups, there's a huge amount of a potential. There's a lot of, we talk about Make in India. We see a lot of organizations are starting investing into developing R&Ds and all other stuffs, but we see electronic industry is being growing. We see that we say automotive is growing at a pace of probably nearly 1 billion. And when we talk about IoTs, when we talk medical industry, when we talk about defense systems or avionics, having mentioned that, all these industries are growing at a very fast pace. But at the end of the day, I see that all the dignitaries in the dais, what they mentioned is that yes, we've been doing one of the state of an art of design, and we are facing a lot of challenges, which is there. We are doing a functionality wise very fantastically good, but what if it is not going to be qualifying it? What is that? If it is not going to be meeting the necessary kind of regulations or the norms or the kind of standards or the criteria which needs to be met. So these all things, it has to be taken into the considerations right at the beginning stages. So having mentioned this, a huge amount of potential which is there as part of product development. I see that whether it is a boon or a bane when we talk about the COVID. Yes, I say that for India it is going to be a blessing in disguise, because a lot of engineering design houses, manufacturing houses, we've been known as service industry with respect to the software. Now India is being recognized second largest the manufacturing hub in the global scenario. And having mentioned this, the kind of a thinking was are we going to produce a quality products? Now, if we talk about, we have fascinating idea. We have exceptionally saying that this product is there where it has to, I have fantastic idea with respect to the drone, but what is that it is needed in order to qualify that? I don't know where to go, what design house I need to choose. whether am I thinking in the right directions to choose the right certifications, right test houses, right design houses, right simulations which I'm trying to do. What am I trying to do here? So it's very imperative that like the startups and the MSMEs has to look into this aspects at the early stages of the designs. Now this early stages when they are into the prototyping, because many instances we see that like, yes, we wanted to produce, wanted to produce to only to India, but later on we find out that like the product is much more potential to get into a kind of like, American market or European market. But these are some things which we as a startups, as an MSMEs, we play a lot of, I say that like, underdog plays. We don't even consider that at the initial stages of it. So it's very important that like that has to be taken at a very early stages of it, because yeah, one is that like, I'm very much in a say where I can able to understand that like any of the startups or the MSMEs, we don't know where to go, whom to choose, what kind of infrastructures, and what kind of certifications. Now, example, I'll just take one of the product, probably a laptop. I say that like if I'm developing any of the touchscreen notepad, when I say that like this has to get into the kind of an oils and gas industry, I don't know like, what, do I need to take those kind of considerations into the designs as part of qualifications? Say that like, these are some things which has to be questions at early stages of a design, but we laterly realize, because when you wanted to qualify the product, you need to take into considerations when it comes to EMC or safety or environmental, or if it is going to be a wireless device like it's RF or ROSH, REACH, WE, all this kind of certifications you need to take into considerations based on the market reach which you are going to get into that. Like, so as we look into that, like, the overall testing, inspection, and calibration kind of an industry, this is a very significant area. I think, India is not looked into that, and it is, as we understand that, like, India is going to grow this TIC industry from 26 billion to 38 billion industry. Only in India, when I talk about this, electronics plays a very significant role. Having mentioned that, like, do we have that kind of a necessary, the competencies, the kind of an infrastructure, the kind of like, probably the investments which is there, which is required, because this TIC is something which is going to be very capital intensive. You need to understand that, and this has to be a kind of initiatives which is being taken care, both from the industry, from the government agencies, and also the kind of like the startups which is there. As we go across, we face a lot of challenges. Today, the technology is very fast. It is growing in a very, those were the days when we were developing a product. It may take easily 1 year to 2 years. But that the time to come to market may take around 2.5 years. Now it is going to be in a month. Not even like you can, going forward, I don't know, like, probably the kind of AI is taking care. It may take very faster pace. But are we meeting the necessary kind of regulatory requirements? So regulatory is becoming a very prominent in India now. Like earlier there was the stages, European countries or the American countries are so stringent. They're saying that like without having any kind of marks, you're not entitled to. So one thing is that if you wanted to go any other countries, basically what they'll ask for passport and visas, right? If you don't have a passport and visa for your product, how you're going to probably enter into that particular geographical area where you wanted to sell your product. So it is very important aspects of it, and we see that like, this is going to be the technological changing aspects of it. It has to be a collaborative effort which has to happen, and at the same time we see that like a lot of startups and MSMEs has to take into considerations, because here the mindset is going to be very important. They need to understand all this kind of an aspects at the early stages of a design. I've seen many of the big, best of the best tier 1 industry organizations, tier 2 industry organizations. They say that like, yes, I've done the design well. As far you have done the design, best of the best abilities, and ensuring that like my product is fantastic, and I'm ensuring my functionality, by functional wise, I'm doing very well. But what if it is going to fail with respect to the kind of an EMC? What if it fails with respect to the environmental? What if it fails with respect to the RF standpoint, or a kind of like, with respect to any of the rush reach aspects of it? But these are some things which is, one is that like, we don't have an awareness is one. Second thing is that, we don't have a kind of like, podium or where we can able to share this kind of an informations, any of the startups, this is something which is completely unaware. So this is, these are the aspects to be taken into considerations at the early stages. With that, when I completed my my entrepreneur, when I completed my corporate journey, when I wanted to enter into entrepreneurship, that's where I realized that, like, yes, when I gone into all the colleges and try to understand about, like, what kind of in order to bring this kind of a competencies, what that it is needed. So if you look about that, nobody wants to get into this kind of a space. The reason being behind is that one is that, like, they in the academic institution itself, we don't have this kind of probably the case studies which is there. So it is important that in the education sector, to the kind of an industries, whether it is a startups or the medium size industries, and also the organizations who are investing onto the next generation technologies. So everybody has to contribute, because the standards are evolving very faster, the regulations are turning out very faster, and we are talking about the kind of like today 60 gigahertz chips or 120 gigahertz chips, but do we have a standards? Do we have a regulations? Do we have a test methods? Do we have any kind of a criteria which is being defined? Now, if that has not been thought through at this stages, it is going to be very, very difficult. So any of the startups or the MSMEs, please put yourself in the thought process well ahead, not getting into a stage of a phase 4 or a phase 5, ensuring that, like, yes, hey, I could have taken this all this kind of design considerations at the early stages of it. So it is, you need to get into phases at the prototype level. Then when you do it at a design level, you need to ensure you do a thorough verification and a validation. Then once you do that, you need to get into the kind of a simulation mode before you get into a kind of a costly affair of getting into laboratory or getting into testeds. You do a simulations for your designs. Yes, two aspects you need to look into that. One is verification, one is a validation. Validation with respect to a different kind of certifications. Not certification in the sense, like, when I talk specifically with respect to the electromagnetic compatibility or the safety aspects or the environmental aspects, these are very, very important. If you take all this kind of things into considerations at the early stages of design, your product life cycle, whatever the kind of iterations you are going to go through, and the later stages of it, that can able to, you can able to reduce very phenomenally. I can able to say these are some things which is only thing is that the awareness is something which I feel like it is lacking in the whole industry, and that needs to be taken into considerations. Anybody who's going to start up or any of the new technologies which you are thinking through. Many instances it so happens that, like, we don't have any kind of a standards, we don't have any kind of a regulatory systems which has already been there. So in that cases, what we need to understand is that, like, lot of standardization organizations which is there with respect to IEEE or ISO or IEC or CSA, lot of standard organizations, there are next generation technology standardizations which is happening. But again, it has to be taken into considerations, all this aspect, but I see that, like, it's a humongous of a task which has been put across with respect to industry contributions, the government contributions, and also the regulatory contributions which is required. As long as, like,